If you could take all the data inside of a database and make it real, how big would it actually be? And I went back to the very first data storage we ever had: paper. This right here is 50 rows of a database on a single page of paper. But of course, that's an absolute nothing burger. So let's raise the stakes a little bit. Now this right here is 1,000 rows of data on pages. Now, it seems like nothing, but just understand this for a second, that a whole entire database I can hold in my hand like this. 1,000 users, for example, is nothing to bat an eye at. If I wanted to find someone named John in a database, for example, doing this in Postgres would do it in like 10 milliseconds, maybe even less. Trying to find it here might take like 20 seconds if I am doing it all in alphabetical order. And like, to be honest, I didn't even try because I just know it's going to be slow and I got things to do. At the end of the day, paper stores data, but it's not really good for retrieving data. I don't know why I'm trying to convince you of this. And for 10,000 rows, we have over 200 pages of paper, which seems like a lot. But think about 10,000 rows for a second. That's a decent size application if it's users, for example. Now, 200 pages is cool. But if I wanted to do like 100,000 rows, for example, that would cost me a small fortune in paper, which A, I don't really want to do or spend the money, or B, I mean, it's just not good for the environment, is it? So I flexed some of my VFX skills. If any of you say what prompt I used, I'm going to kill you. 100,000 rows. That's like 2,000 pages of paper, which again, doesn't seem like much at the moment. And 100,000 like users say, that's obviously just one table. This is not how databases work for the most part. But what happens when we have over 1 million rows, which, we could add a pets table and get that pretty easily, especially with 100,000 users? Well, that would equal to 20,000 pages, as you can see right here. Basically the same size as me, 2 meters tall. This is a lot like the picture of Margaret Hamilton standing next to the moon code or whatever, except for me, it's not as impressive. Or really impressive at all. Now, in a database, this gets queried instantly. You don't have to do any waiting whatsoever. This probably happens so many times per second. And these two stacks aren't just sitting next to each other for the fun of it. If I wanted to find out which pet belongs to which person, I'd have to grab a pet, check the user ID, come back here. Yeah, I give up. Well, this is what's called a join. Databases do it in milliseconds. I do it in, never. I'm never finishing. On paper, you just need a lot of time. And joins are one problem. But here's another. What if I just need to find one specific user in this giant stack? Well, this is where indexes come in. An index is basically a second skinny stack, just the names in order, with page numbers pointing back to the original, smaller than the main stack, way faster to flip through. Now imagine adding sticky notes for letter ranges A through E, F through J, all the way down. I've got the alphabet memorized, hopefully you do too. So when someone asks me to find John, remember when I said this would take like 20 seconds before? Well, it's done now. And that's an index. And real databases don't stop at one. You can have indexes on emails, on dates, on anything you query a lot. That's just how Postgres pulls one row out of 1 billion in milliseconds. Okay, 100 million rows. How tall will that be? Well, the database chugs a little, as it should. Queries take a little bit longer, especially when you're doing this. With paper, that's 2 million sheets. So in here, well, that's like 20 stacks of paper my height. Yeah, I can't even walk in here anymore. That's 10 tons of paper and almost $200,000 in printer ink alone, which I didn't even factor in this, to be honest. And that's significantly more than my entire camera kit. VFX saved my life here. But if I was to stack it up all in one, well, we're getting roughly to the height of the Eiffel Tower, all fitting inside of a single database. And this isn't some sort of magic box. It's Postgres, the GOAT of databases, which you can easily use with the sponsor of today's video, Supabase. You've already heard about them, but Supabase helps you build your project in days rather than weeks with everything you need for a backend like Postgres, authentication, edge functions, storage, and real-time subscriptions. You can use Supabase with basically any framework you or your AI agent decides for you, and Supabase scales with you. Some of my favorite features is branching of your entire project or read replicas for faster speeds to all of your users. To get started, you can go to the Supabase dashboard, or if you really want to go crazy, download the MCP server and just get your agent to do it all for you. Thanks to Supabase for sponsoring today's video. So what about 8 billion rows of data? You know, as if it was on one table or something. Well, taller than any building in Canada. That's what a billion rows looks like when you pull it out of the machine and make it real. 20 million sheets of paper, that's 2 kilometers tall. And of course, we could argue about trillions and whatever, but I thought, why don't we take some real life use cases and stack it up, see how that goes. So at this scale, companies aren't just storing data, they're drinking from a fire hose essentially. So what does their numbers look like on paper? Spotify generates 1 trillion events every single day. Every play, every skip, every search, most of that flows through streaming pipelines, not a single database. But even if you take that same idea of like logs or something being a single row, well, it still adds up pretty quickly. And I did the math. Printed, that stack passes the International Space Station every single day. Uber ingests over, let's see here, 6 trillion rows of data per day across almost 20,000 databases. So I ran the numbers on just one day of storage. That stack of paper reaches from Toronto to Tokyo, and tomorrow they do it all again. Now, if we have something like Facebook, they have over 3 billion users, trillions of interactions. Their data warehouse is past 300 petabytes years ago. I mean, and if I try and calculate this one, you're past the moon at this point. I couldn't even figure it out because it's just so much data. But imagine all of that just one day at a time. I start off with a question, how big is your data if you make it something physical? And honestly, the answer is pretty surprising. 1,000 rows fits in my hand, 1 billion towers over my house. And the software that we're using every single day is generating space level heights almost every single day, which makes you really think like, wow, that's just insane. And despite us knowing how much data and information we're going through on a daily basis, that kind of scale makes us think like, what crazy technology is able to retrieve the information at millisecond speeds? So next time you spin up an empty database, understand you're opening up a gigantic file cabinet that could be endless. And if you want to start your application with Postgres, make sure you use Supabase. It's a great platform. I use it for my clock car video that you might have seen, as well as almost everything. So thank you, Supabase, for sponsoring today's video.